Okay, have you taken that problem, all of you?
No, sir.
No. Okay, because of internet connectivity I lost the connection. Okay, so anyhow I will upload that solution in the video, and also I will upload that solution in my PDF also. Okay, you give one page. Okay, one page जोड़ दो, next problem लिख दो.
Okay.
Everyone. Okay, we will go for the next problem. One page is sufficient. Okay. See, I will upload this figure also. Okay, and this PPT. So this is T section. Okay, he has taken like this. This is one T section. You can try this way, all these examples. There is a I section. So see, all of you, is it audible?
Yes, sir.
Yes, sir.
Now see, is it symmetrical about x-axis? x-axis मतलब मैंने क्या करते? Yes, yes. So I will cut like this. Okay, मैंने fold करते. Is it symmetrical about x-axis? No.
No.
It is not a symmetrical about x-axis. I will cut like this. Is it symmetrical about y-axis? Yes.
Yes, sir.
Yes. If it is symmetrical about y-axis, which term is equal to 0? X bar is equal to 0. See, here he has given. Selecting the coordinate system due to symmetry, centroid must be lie on y-axis. Therefore, x bar equal to 0. Okay. Now, composite section may be split into 3 rectangles. This is rectangle 1, this is rectangle 2, this is rectangle 3. See, rectangle 1 ka area is 100 into 200. Okay. So iska 100 into 200 आ गया. Next इसका y1 calculate करने का. So y1 means along y direction. Correct? So where is the reference axis? Where is your reference axis first of all? The reference axis is this is your reference axis, x-axis, and this is y bar is this is x. Okay, y you have to calculate y1 from the which axis? From the horizontal axis, correct? Okay, that is you have to calculate from this point to till its CG. Okay, इसके लिए इधर से इधर कितना है total? This is 30, then this is 100, then this is 20 by 2. Okay,
Yes.
100 plus 30, 130 plus 20 by 2.
150.
How much it is?
140.
140. Or you can also do like this. Total is how much?
150 minus 10.
150 minus 20 by 2. 140. वैसे भी कर सकते. Again, correct answer?
Yes, sir.
Okay. Next, A2. A2 means second section ka area. Then Y2 means CG of the second section from the reference axis. That is, this is 30 plus second section का total height कितना है? 100 divided by 2. So 30 plus 100 divided by 2, that is equal to 80. Then third rectangle, this is area is 150 into 30, so you will get 4500. Then y3 you have to find out. Y3 is from this reference axis to the CG of this one. Okay, total is 30 by 2, that is 115. Is it clear, everyone? Then applying your y bar value formula, you will get the same thing. Is there any doubt?
No.
Okay.
No, sir.
Okay, this formula you have seen. Okay, so do you have any problem in finding the centroid? Centroid find out करते वक्त कुछ problem है क्या?
No, sir.
Okay, so if you are perfect with the centroid, then we will go for the moment of inertia. Okay, in the moment of inertia, you should find out the centroid first. Once if you find out the centroid, then only you can calculate the moment of inertia. Okay, So what does this moment of inertia is nothing but it is second moment of force. Okay, I will just read and explain. Just concentrate. लिखो ना. Yes, okay. So whatever problem I have shown, okay, you can solve these two problems. Okay, this problem you have to solve in your notebook. Okay, all of you have to solve this problem, and also trapezium problem. I have solved that one. You just once again go through the video and you can solve that one also. Okay, this one is simple. I have taken this T section. Okay, but only magnitude is different. Okay, all of you, are you concentrating? So next point is moment of inertia. So what does this moment of inertia? Moment of inertia. Moment of inertia of an elementary area about any axis is given as product of area of the element and square of its distance from the same axis. So moment of inertia is denoted by I. I is the product of area of the element. Area of the element is A into square of its distance. I will take square is equal to R, or you can take H also. Okay, R square or H square. Okay, its distance from the same axis. What is the area unit for area? mm square. एलिमेंट मीन्स पूरा जो बॉडी दिया ना प्लेन में, हाँ उसका एरिया. ओके, सो एरिया का फॉर्मूला क्या है? यूनिट इट मे बी mm square, it may be meter square, it may be centimeter square. Okay, then if you take mm, then the distance r is what? Square of its distance. Distance का यूनिट क्या है? That is also centimeter or meter or mm. It is also equal to mm square. Then what is the unit for the total moment of inertia? Mm raised to 4 or meter raised to 4
Yes.
or cm raised to 4. Okay, this is one of the objective question. Unit for moment of inertia. What is the unit for moment of inertia? Mm raised to 4 or cm raised to 4 or meter raised to 4. So option D is all. What is answer? All is answer. Or in the question paper में कैसे रहते? mm cube, mm square, mm raised to 4, mm. So which one is the formula? Mm raised to 4 is the unit for moment of inertia. Okay, all of you read on this statement. Moment of inertia. Moment of inertia. Moment of inertia. Moment of inertia of an moment of inertia. Moment of inertia of an elementary area about any axis is given as product of area of the element and square of its distance from the same axis. Have you written?
Yes, sir.
Okay. Don't draw any diagram and all. Just you should know its definition. Okay, before that one, all of you read on this one. It is denoted by, all of you read on. It is denoted by I is equal to A into h square. A into h square. Unit of moment of inertia, mi. Unit of mi. Yes, it is mm raised to 4 or cm raised to 4 or meter raised to 4. Okay, these 2 points are important. Complete?
Yes, sir.
Okay, next one more point, all of you read on. Polar moment of inertia. Polar moment of inertia. Polar moment of inertia. Okay, 1 minute, don't read. Before this one, whatever you have written moment of inertia, okay, you have written here. So one more point you can write. So moment of inertia about xx, ixx is equal to ixx is equal to integration of, see, only if it is only one element to area a into h square I have written, correct now? If it are multiple area there, then at that time integration of all the areas, integration of area, that is dA into with respect to y, I have to take y square. If you take moment of inertia about y axis, then integration of area dA into x square we have to take. Okay, these two are formula. Okay, all of you read on this one. This is moment of inertia along x-axis. Moment of inertia along x-axis, along x-axis. And this is second one is moment of inertia along y-axis. Y-axis. So this is also important. Okay. So what is the moment of inertia along x-axis? Ix is equal to integration of dA into y square. Moment of inertia about y-axis is equal to integration of dA into x square. Is it clear, everyone?
Yes, sir.
Yes.
Yes. Now we will come for the polar moment of inertia. Yes. Read on polar moment of inertia. Polar moment of inertia. The moment of inertia about an axis, comma, which is perpendicular to the plane of an area, and is known as polar moment of inertia. Polar moment of inertia. Polar moment of inertia. Okay. So just all of you concentrate. Don't write anything. See, this is one figure is given. Okay. Is it standard figure? Section? Is it a rectangle, triangle, or trapezium or circle? Hai kya?
No.
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 In general figure. Okay. So area, he has taken one small element. Its area is equal to dA. So I want to find out its entire area. How to find out entire area? Summation in terms of mathematical में कैसे लिखते हैं? Integration of dA. मतलब क्या है? It is total area आएगा ना? Okay. What is our moment of inertia का formula क्या है? Total area into h square distance. अभी देखो, this is x axis, this is x axis, correct? Okay. I want to find out the moment of inertia about x axis. Integration of dA into what is the distance between the centroid from the x axis. इधर से इधर कितना distance है? This is y into y square. That's what I have written. Okay. अभी moment of inertia about y find करने का है. So this is y, correct ना everyone?
Yes,
What is the
sir.
distance of centroid of this section from the y axis? This is x bar or x. Okay. Total area is equal to integration of dA into x square. Correct? Suppose so these two are perpendicular, correct? I will take one more axis which is in z axis. Okay, that is perpendicular. Okay, I say right. Okay, you have seen. I see here x. This is x axis. This is y axis. This is perpendicular is z axis. So I will take the centroid of this elemental area from the origin. From the origin is r. Okay. So how to determine the polar moment of inertia? That is Izz is equal to integration of dA into r square. Okay, but r is not known. In that case, what you have to do is Izz is equal to Ixx plus Iyy. Okay, this one you have to do. Is it clear, everyone? Moment of inertia about xx, about yy is along x-axis and along y-axis. Polar moment of inertia is, it is perpendicular to the plane. That is Izz. Okay, so all of you write on this. Draw this diagram. Only this diagram you have to draw. Instead of rho, you can draw it as r. लास्ट ईयर था क्या साइंस में? Only draw this figure, first figure only. Okay, don't draw second and third. Don't draw this. First one. Okay, so you can write down moment that is Izz is equal to, okay, Izz. You can write zz. This is z axis. Izz is equal to, it is integration of dA into r square. Okay, completed all of you?
Yes.
Nice. Yes, there are two more theorems. Just a minute, I will come back to this point. So first point, okay, right on. Next point, radius of gyration. Write this point. Radius of gyration. Now, I think all of you have studied in your 12th class, correct? No?
Yes, sir.
Now,
Yes.
it is defined as, see, all these points are important for the multiple choice questions. Okay, he will give a definition and he will ask, what is this? So it is defined as the distance from a given axis, the distance from a given axis of the point at which the entire area is supposed to be concentrated without changing the moment of inertia about the given axis Okay, what is this moment of radius of gyration? So you know moment of inertia. Okay, so first radius of gyration is it is a distance. It is distance from a given axis of point at which the entire area is supposed to be concentrated without changing the moment of inertia. See, if you are not considering this term without changing the moment of inertia, it would be centroid. Okay. उधर also some हम same लिखे थे ना. It is the distance of a given axis. That is, it is a point in which whole area is assumed to be concentrated लिखा था. इधर also be distance from the given axis of the point at which the entire area is supposed to be concentrated. But again, what we reckon? Without changing the moment of inertia. Okay. So see, this is the figure. If he has taken one elemental part A. Okay, its area is A. So this is centroidal axis. Okay, so distance of this area from the centroidal axis is given axis is K. This K is nothing but your radius of gyration. It is denoted by letter K. So how to find out this K, sir? So we know that moment of inertia is equal to what is area into distance square. Okay, that distance I will take it is A into K square. So this K I have to calculate. That is K is equal to I divided by A in under root. So if you have calculated this moment of inertia about x-axis axis, you will get Kx. If you have calculated moment of inertia about y-y axis, then that will become Ky. Is it clear, everyone? Yes, sir. Okay. Write on this one first one. I is equal to K square into A. I is equal to K square into A. Diagram not necessary. Diagram is not necessary. Just write down these two formula. I is equal to K square into A. Next, K is equal to summation under root of I into A, I by A. Then Kx is equal to root of Ix by A. Then Ky is equal to root of Iy by A.
के z नहीं आएगा क्या?
No, it's already we are determining radius of gyration with respect to given moment of inertia Ix and Iy. So we are calculating moment of inertia along x-axis and along y-y. With respect to z, we are not doing. That is become polar moment of inertia.
Yes, sir.
Have you taken?
Yes, sir.
Yes, sir.
Okay. Just concentrate. Don't write on anything. What are the characteristics of moment of inertia? It is the measure of an object's resistance to change in its rotation. Okay, whenever a body is rotating, okay, how much it is resisting. If the moment of inertia is maximum, it means it will resist maximum rotation. If the moment of inertia is low, minimum or less, then it will resist very less rotation. Then it is also defined as the capacity of a cross section to resist the bending. See, in your house, there is a beam slab, correct? This is beam. Okay, so whenever the load will comes from the superstructure to the this beam, okay, the beam is undergoing bending. Beam क्या ऐसे होता? This is bending ऐसे होता, correct? So in order to avoid this bending, we are considering. But these are the beams. Okay, so in order to avoid this bending, we have to give maximum moment of inertia. So which term we have to? So whenever you are taking, this is the cross section. Okay, so this is B, this is D. Always D is increased. That is, depth of the beam is increased. In order to increase the moment of inertia, depth is increased. Why depth is increased? Why not B? We will come to know. That is from the formula. Okay, it is defined as the capacity of the cross section. Then it must be specified with respect to chosen axis of rotation. It is equal to, usually quantified as meter raised to 4 or sometimes kg meter. If you are considering mass into distance you have taken. So maximum you have to take meter raised to 4. Is it clear, everyone?
Yes, sir.
Yes, these are some of the characteristics. So this is the formula. Okay, so for the simple figure, all of you read on first one, rectangle. Characteristic, just read on this. Moment of inertia. कैंटीन का क्या? हाँ 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 लोडिंग फ्रेम. हाँ करेक्ट. Okay, first one, read on moment of inertia. For the standard shapes, this one you have to remember again. These are standard formula. Okay, while solving the formula, we will repeat. First one, rectangle. First one. Yes. Any doubt? Sorry. मुझे समझ नहीं. Yes. कुछ डाउट है क्या? आपको वॉइस ब्रेक हो रही है. आपको वॉइस हेलो.
कैरेक्टरिस्टिक नहीं निकलेंगे.
कैरेक्टरिस्टिक्स मत लिखो, वो नहीं चाहिए. ओके, जो इंपॉर्टेंट है वो दे रहे. दैट इज नॉट इम्पोर्टेंट. हाँ, फर्स्ट वन rectangle. Draw this rectangular shape. Its width is B and its depth is H. Sometimes in this problem he has taken H. Sometimes it will be D also. Okay, D. Okay, you don't write anything. Okay, I will dictate. Just draw the diagram. This is rectangle. What are the reference axes in this figure?
X and
Y are reference. What are the centroidal axes? X dash and Y dash. Correct? Okay. Okay. First, I will write moment of inertia about x-axis. Okay. I-x-x. Standard formula is BH cube by 12. BH cube by 12. You can write BH cube by 12 or also you can write BD cube by 12. So here he has taken H. That's why I have used H. If you take D, then it will be I-XX is equal to, can you tell me? BD cube by 12. Okay, so B is along X direction. Okay, D is along Y direction. See, I have taken XX. I have written this one. So now what I will write? I will take along YY. So it will split along y by. What is along y by? Which dimension is there? D. Okay, so D. Then second quantity क्या है? B. dB cube by 12. dB cube by 12. Is it understood, everyone? So along x-axis, what is x-axis? B, first term. Then second term cube करने का. Then along y direction में करना है तो first term y direction में लेने का. Then second term का cube लेने का. Okay, depends on your figure and depends on your question. Which term is asking. See, B का यूनिट क्या है? mm. D cube का mm cube. Total क्या हो गया? mm raised to 4. So is it correct? Moment of inertia? Yes, this is one. Okay, so write down, all of you write down. Ixx and Iyy. Only write down these two. Ixx and Iyy. So this axis and y means it is about centroidal axis. Huh? It is about centroidal axis. That is x dash y. So simply it will become confusion. That's why I have written xx and y. It is with respect to centroidal axis. Whatever moment of inertia you are calculating, no, it is with respect to centroidal axis. Okay, is it clear? Okay, second one. All of you write down second one. Second one is triangle. Second one is triangle. Triangle. So its centroid कहाँ पर है? This is the centroid. Okay. This is C. He has given C. So I about xx. I about xx is equal to bh cube by 36. bh cube by 36. bh cube by 36. This is from the centroidal axis. Huh? So sometimes you should know what is about base. I about base. That is bh cube by 12. bh cube by 12. You should know this one also. bh cube by 12. Ixx is centroidal axis. I base is bh cube by 12. Write on these two. Ixx equal to bh cube by 12. I base is equal to bh cube by 12. See, if I want Iyy, how I will write Iyy? See, Ixx xx है ना, so b लिखा था. अभी Iyy चाहिए तो हाँ, Iyy is equal to h b cube divided by 36. Correct? Yes, only interchange the values. Okay, cube ऐसे ही रखने का, only h become b, b become h. Okay, next we will go for the third one. Circle. Third one, circle. Draw this diagram. Okay, circle. Have you written? Okay, Ixx. See, this is symmetrical about both axes. Circle.
Yes,
Then Ixx is equal to Iyy because x bar is equal to y bar. Correct?
Yes.
X bar is equal to y bar आता है ना? So Ixx is equal to Iyy is equal to pi r raised to 4 divided by 4 here he has written pi r raised to 4 divided by 4. So if you know radius, you can substitute. If you don't know the radius, then pi 4. What is r? R is equal to d by 2. Correct, everyone? So d by 2 whole raised to 4. Whole raised to 4. So pi d raised to 4. 2 raised to 4. How much it is? 16. 16 into 4. 64. pi d raised to 4 upon 64. वैसे भी लिख सकते और pi r raised to 4 by 4 ऐसे भी लिख सकते. Okay? Okay. All of you read on. Whatever formula I am giving with respect to centroidal axis. Okay. Have you written? Okay. Okay, see, this is semicircle. So all of you read on if you want. Read on. Fourth one is semicircle. Semicircle. What is moment of inertia for full circle? Full circle. फुल सर्कल का कितना रहता है मोमेंट ऑफ इनर्शिया?
pi r square
pi r raised to 4 divided by 4 फुल सर्कल का. ओके, आई वांट हाफ सेमी सर्कल का डिवाइडेड बाय 2, दैट इज pi r raised to 4 divided by 8 pi r raised to 4 divided by 8. ओके, सपोज क्वार्टर सर्कल चाहिए तो pi r raised to 4 divided by a 4 था, अभी 4 किया divided by 16. pi r raised to 4 divided by 16. Okay, don't write anything. कौन सा? no 4 divided by 1 रहता ना, 4 divided by 1 रहता, इसके लिए pi r raised to 4 divided by 4 into 1 by 4 हो गया. So that is equal to pi r raised to 4 divided by 1600. Okay, just write down only one semicircle का लिखिए. Don't write anything. Just write down this one. आपको एग्जाम में मैक्सिमम रेक्टेंगल, ट्रायंगल, सर्कल, सेमीसर्कल, मैक्सिमम सेमीसर्कल. You can remember up to 4-5. Ellipse don't write down. Okay. Now this is not required. This is very rare. Okay. So this must be sufficient. So this is I is equal to pi r raised to 4 divided by 4 tha divided by 2. That is equal to pi r raised to 4 divided by 8. That's sufficient. Is there any doubt to anybody? Area. Moment of inertia. I means moment of inertia. I is moment of inertia. Okay. Don't get confusion. It is not area. It is moment of inertia. What is the unit for moment of inertia? Remember raised to 4. Arc का power कितना है? 4 है ना? So all देख के समझ में आने का. Whether it is a area or whether it is a moment of inertia. R का power कितना है? If it is a 2, R का power 2 है तो that is area. Here R का power 4 है. That is moment of inertia. Okay.
वेट कैसे आया?
सर 2 आया ना.
सी मोमेंट ऑफ इनर्शिया का सर्कल का कितना? pi r raised to 4 divided by 4. करेक्ट है ना? एवरीबॉडी
4 बार.
एक मिनट इधर देखो. एक मिनट. सी मोमेंट ऑफ इनर्शिया फुल सर्कल कितना है था? pi r raised to 4 divided by 4. करेक्ट है?
यस सर.
उसका हाफ कर दो. हाफ किया तो कितना आता है? pi r raised to 4 divided by 8 आता है ना?
यस सर.
Yes, clear or no? Is it clear?
Yes, sir. Clear.
So for a full circle, moment of inertia for full circle, pi r raised to 4 upon 4. This is for a full circle. Moment of inertia I am writing. It is not about the area. You have to keep this in mind. It
Yes,
is
sir.
moment of inertia. So abhi moment of inertia for the semicircle I want. This entire term divided by 2. That is nothing but pi r raised to 4 divided by 8.
Yes, sir.
Don't write down these two. Okay, don't write down. See, he has given directly. What is moment of inertia for the rectangle section? Ixx bh cube by 12. That is bd cube by 12. Here he has taken h. If you take d, that is bd cube by 12. Okay. Then here he has taken radius of gyration. You can calculate this one. Okay, you will get h by root 12. Okay, after calculation, don't necessary to remember. और एक triangle का. What is the triangle का? bh cube by 36. It is with respect to centroidal axis. About base चाहिए तो bh cube by 12. Okay, how that will get, we will come to know. Then circle का क्या रहता? Pi r raised to 4 upon 4 or pi d raised to 4 upon 4. Is it clear, everyone?
Yes, sir.
Okay. Then semicircle का क्या ये था? 0.11 raised to 4. See here, yes, here. ये calculate करो, pi upon 8 करो calculator में. Pi divided by 8. 0.39. Okay. एक मिनट. 0.39 है. Pi mean 5 नहीं. 22. Pi. Correct. You should get 0.11. Pi divided by 8. 0.392. All of you are getting 0.392.
Yes, sir.
Yes, sir.
You should get 0.11/4. Okay, I will check this point. Okay, कहाँ पर है वो? I will check this point and I will explain. Then इसका value आते हैं. Okay, don't worry about all these things. Then, so first is you have to find out moment of inertia. Okay, for the simple, you have seen moment of inertia for the standard figure. Okay, standard area you have found out. Then we will go for the moment of inertia for the composite area. Okay, this will be important for exam. He will give some simple figure. He will ask what is the moment of inertia. Okay, now I will take, you can take a break. Okay, कितना चाहिए? 5 minutes, 10 minutes, 10 or 15 minutes. How much you want? Break. 15 minutes, 10 minutes or 15 minutes. आप जैसे बोल. Now it is 11:17 हो गया. 11:30 को will come back.
Yes, sir.
In my mobile it is 11:17. 11:30 को वापस आ जाएगा. Okay, so we'll stop now.
Okay.
We'll continue at 11:30. Okay, we will solve the problems on the composite section. That is moment of inertia. Okay. Yes.
Yes.
So, now I will stop. We'll come back at 11:30. Okay. Everyone, all of you have to come back. So I will take the attendance later.
Yes, sir.